Hello, this is the second Physics 2212 lab charge tapes revisited. The purpose of this lab is to expand upon the findings of the first charge tapes experiment by creating a flow script model involving dividing the tapes into small segments and treating each of these segments as point charges. The concepts we'll be testing in this lab stem from the concepts we used in the last lab. They include Newton's second law, Newton's third law, the formulas for the electric field of a point charge and electric force, and linear superposition. So just a preview of the last lab, I achieved a value of 8.75991 times 10 to the minus 9 coulombs for my charge Q. And with the updated model in this lab, I got a new value for Q of 2.07738 times 10 to the minus 8 coulombs. Again, from Newton's second law, the gravitational force points equal and opposite to the electric force. And the assumptions in this lab are the same. We're ignoring air resistance, assuming each U-tape has the same charge. We're assuming the charges on each U-tape are evenly distributed, that each tape can be separated into segments of equal charge, and the total charge on each U-tape is the sum of the charges of the segments. And here are the results of the last lab with the gravitational force and electric force canceling out. Okay, so now let's get into our glow script code for this lab. I started by plugging in my constants like 1 over 4 pi epsilon, the charge of an electron, atom length, and the gravitational constant. And here, starting in line 25, I've put my data in from lab 1. And in line 32, I entered the Q I calculated from lab 1, but ended up changing it using guess and check so that the magnitude of the electric force could more or less cancel with the magnitude of the gravitational force. Okay, so in this part, I defined my electric field function, and this is where the line of charge is defined. And here I created the top and bottom tape objects, and this also shows the nested for loops, which demonstrate superposition. And here is the visual output of the glow script model. The yellow force represents the electric force, and the green force represents the gravitational force. And the orange arrows represent the electric field with n equals 50, so there are 50 arrows. And the red dots, which are kind of covered by the orange arrows, represent the system, and the blue dots represents the bottom tape, which we're considering as our surroundings. And we computed that a Q value of 2.07738 times 10 to the minus 8 coulombs results in an electric force that directly counteracts the gravitational force. And this is over double the value of Q that I found in lab 1. Okay, so what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you used your experimental data to produce a single point charge model to the value you got with your line charge model. And we said before that this new Q from the line charge model is over 200 times the Q from the point charge model. And so why do these estimates differ? Which value is more likely to be closer to the real value and why? And the estimates differ because they use different levels of precision. The line charge model is more likely to be closer to the real value because it uses smaller step sizes and is more akin to real life. And so we can think of each piece of tape as being composed of an infinite number of point charges and linearly superpose each point charge as we've been doing. And the more point charges we have, the more accurate our answer. All right, that's all I have for today. Thank you for watching.